Hello and welcome. In this video, we're going to talk about how to take derivatives of logs that are common logs, how to take derivatives of logs with bases that aren't e, so not natural log. And then we're going to talk about logarithmic differentiation. So let's go ahead and jump right in. So we have talked about how we can take the derivative of natural log, and that the derivative with respect to x of natural log of x is equal to 1 over x. What we haven't talked about is what happens if we have another log. What if we had log base 2 of x? How do we take the derivative of that? There should be an approach that we could use to take the derivative of that. So what we learned in previous classes in Algebra 2 is how to change the base of a logarithm. And in Algebra 2, often you were changing the base from natural log back into a regular log, but the way that we change that base, the way we use the change of base formula, which is what this is by taking natural log of whatever you're taking the log of over natural log of that base. So for example, if we had log base 2 of x, according to the change of base formula, this would be natural log of x over natural log of 2. So this is a conversion that you need to remember, because really anytime you see an log, a common log, you're going to rewrite it as a natural log. But if we know that this change of base formula is true, we could actually take the derivative of both sides so that we could have a formula, so to speak, for the derivative of a common log. So if I take the derivative of both sides here, this is going to give me the thing that I want to know. The derivative of log base b of x is going to equal, well, remember here that b is just some number. So this is really, I'm actually going to write it this way, some number times natural log of x. And what is the derivative of natural log of x? We just said that it's 1 over x. And let's just write this a little bit nicer. This is x times natural log of b. So the derivative with respect to x of some common log, log base some other number of x, is 1 over x natural log of b. So if we go back to this problem, we can say the derivative with respect to x of log base 2 of x is equal to 1 over x natural log of 2. So this is just a helpful formula that we can use to manage and manipulate common logs. So let's work through some more practice with this first. And I am actually going to recommend that most of the time your life is going to be easier to first rewrite using the change of base everything to be in terms of ln. So let's go ahead and look at some examples. So here are 3 examples where we are given a common log instead of a natural log, and what we're being asked to do is to take the derivative of each. So again, the very first thing that I want to do is I want to rewrite each of these 3 problems using ln instead of using the common log. So based on that formula that we had before, and I'm actually going to rewrite this as 1 over natural log of the base times natural log of everything else. So natural log of x times the square root of x plus 1 over 2. So the very first thing we're going to do is just rewrite using natural log. So here, if I rewrote this, f of x is going to equal, if there is no subscript here, this is log base 10. So 1 over natural log of 10 times natural log of x squared plus 3x minus 5. So why don't you go ahead and pause the video and just try and do this very first step, rewrite number 3 using natural log. Okay, so hopefully you've had time to try that. If I rewrite this using natural log, I'm going to have 1 over natural log of 14 times natural log of x to the negative 14th power. So step 1, rewrite using natural log. Step 2, use or expand with properties of logs. So if I look back at number 1 here, Remember that that 1 over natural log of 3, that's just some number, but I can use properties of logs to expand what's inside here. So natural log, that numerator is going to become addition, natural log of x plus natural log of, I'm going to rewrite this as x plus 1 to the power of 1/2, minus the natural log of the denominator, so minus natural log of 2. Let me clean that up for you. There we go, that looks more readable. And then there's actually one more thing I can simplify. I could move this 1/2 to the front of that term. So y equals 1 over natural log of 3 times natural log of x plus 1/2 natural log of x plus 1 minus natural log of 2. So I still have not done any calculus yet on this problem. I rewrote it in terms of natural log, and then I used properties of natural log to simplify, even though it looks more complicated now, to simplify what's there. It will be simplified in terms of me finding the derivative. But let's just focus on step 2 again for number 2. So I'm just going to come down here. F of x is going to equal 1 over natural log of 10 times, I can't actually expand anything here, natural log of x squared plus 3x minus 5. I can't expand anything here because everything that's happening in here is addition. I can expand multiplication and I can expand division like I did on number 1, but I can't expand addition and subtraction. So there are no properties of logs. I just, for whatever reason, rewrote exactly what was there. For number 3, I want you to ask yourself, could you rewrite what is there using properties of logs? Are there any properties of logs that could enable you to rewrite what's inside here? So hopefully you realized you could drop this exponent down, so that would be negative 14 times natural log of x. So the very first thing we did was rewrite each term using natural log of n, and that came from the formula up top, which said that log base b of x is equal to natural log of x over natural log of b. That's how I did that first step for red. Then I used properties of logs to expand in cases where I could, because that's going to make the derivative work easier. Now, step 3 is going to be, we actually need to take the derivative. So here, y prime is going to equal, I'm going to keep 1 over natural log of 3 in red. We're not taking the derivative of that. That is just a scalar that is being multiplied into the function. The derivative of natural log of x is 1 over x. The derivative of 1/2 natural log of x plus 1 is 1/2 times 1 over x plus 1 times the derivative of x plus 1, which is just 1. And then minus the derivative of natural log of 2 is just minus 0. So I'm going to just clean up my final answer here. Y prime is going to be 1 over natural log of 3 times 1 over x plus 1 over 2 times x plus 1. And I don't need you to expand that out. You could if you wanted to, but I really care that you're getting the calculus down here. So for number 2, f prime of x is going to equal 1 over natural log of 10 times the derivative of natural log of this is 1 over that times the derivative of that function. So the derivative of that is going to be 2x plus 3. So if I clean this up just a little bit, 1 over natural log of 10 times 2x plus 3 over x squared plus 3x minus 5. That's going to be our final answer here. Why don't you go ahead and see if you can finish off number 3 on your own, and then unpause the video and see how you did. Okay, so hopefully you had time to work through this. I'm still going to have 1 over natural log of 14 here, times the derivative of negative 14 ln x is negative 14 over x. So I'm going to just make this look a little nicer and write it as one fraction. Y prime, or dy dx, is equal to negative 14 over x natural log of x. So if you are ever working through a problem that has a common log, an log log, first rewrite it using natural log. Then, if there are properties of logs, expanding, condensing, the power rule, anything that you can use to help you out, do that. Then take the derivative. Sometimes you might have to use the chain rule like we did on number 2, because the thing we were taking the natural log of that inside function has a derivative that's not 1. So let's move on to the very last topic for today, which is logarithmic differentiation. So what we have done and been doing for what feels like a very long time is we have found derivatives of things like x to the third power. And we have done that using the power rule, which tells us we can drop our exponent down and we can decrease our exponent by 1. We have not, however, taken that derivative if the exponent is a variable. So we have done that when the exponent is a number, but we haven't done this when the exponent is the variable. So this is a new challenge. If you try to just use the power rule, you end up getting back exactly where you started. And what I mean by that is, if I tried to use the power rule, which doesn't apply because this is not an exponent, or sorry, this is not a number, it is an exponent, I would get x times x to the power of x minus 1. But if I simplify that, 1 plus x minus 1, I'm going to just get back to the power of x minus x. That doesn't really make any sense here. So the approaches that we have taken before are not going to work on this problem. So what can we do to solve that? If you think back to Algebra 2 and pre-calculus, oftentimes you were asked questions where you were using a formula and you were asked the question, how long will it take? How long will it take for your bank account to get to this value or for the money to increase by this amount? How long will it take for some compound to decay a certain amount? And if you remember what you did, the goal there was if you need to solve for an exponent, or in this case, I need to get this exponent out of its place, what you can do is take the natural log of both sides. And by taking the natural log of both sides, you end up getting the exponent down out of its exponent spot. So what do I mean by that? If I'm not taking the derivative quite yet, but if I just look at this function here, if I took the natural log of both sides, natural log of y would equal natural log of x to the x, which would be the same thing as natural log of y times x, natural log of x. So here's why this is helpful. And again, we are going to take the derivative, but we haven't done that yet. This is helpful because I know how to take the derivative of this. This is just a product rule. I know how to take the derivative of this. This is just the derivative of natural log. So by taking the variable out of the exponent, I can now take the derivative of what is there. So the very first thing that you're going to do when you use logarithmic differentiation is you're going to natural log both sides to get your exponent down. Actually, instead of saying that, let's say to bring your exponent down. And we're allowed to do that just by properties of log. So what we did here was we took the natural log of both sides, and now I can actually take the derivative of both sides. So the next thing that we're going to do is we're actually going to take the derivative of both sides. So if we take the derivative, I'm actually just going to say, well, if we take the derivative of natural log of y, we end up with y prime, or dy dx. I'm going to just write that as y prime over y, because the derivative of natural log of y is 1 over y times dy dx. But instead of writing dy dx, I'm just going to write y prime. So y prime over y is going to equal, and then over here we're going to have to use the product rule. So I'm going to use two colors so you can see what I'm doing with each function. The derivative of x is 1 times the second function, plus keep the first function the same and multiply that by the derivative of the second function. The derivative of natural log of x is just 1 over x. Now, my ultimate goal is to solve for y prime. So to do that, what do I need to do? I need to get rid of this y over here. And how do I get rid of it? Well, y prime, or dy dx, is dividing by y. So to get rid of that, I'm just going to multiply it on both sides. So step 3 is going to be multiply both sides by y. So that's going to give me y prime equals y times natural log of x plus, this is just going to simplify to be x over x, or 1. Now my final answer would be best if it didn't have x's and y's. So we need to replace y with the original problem. What I mean by that is up here, we know that y is equal to x over x. So down here, I can just rewrite y as x to the power of x because that is what y is defined to be. So now my final answer, my derivative, is completely in terms of x. So we're going to work through this process multiple times. But what we're doing each time is asking ourselves, is there a variable in the exponent? If so, take the natural log of both sides. Then take the derivative of both sides. That'll give you y prime over y equals, and then whatever you did with the derivative on the right-hand side. Then you're going to multiply both sides by y, and then you're going to plug back in what y was. It is really procedural, and after you do it a few times, it gets to feel a little bit more normal. So let's just do 3 more examples together, and then we'll wrap up this video. Okay, so here we go. We have y equals x minus 2 to the x. I can't take the derivative of this using the power rule because the exponent is a variable. I want to get the exponent out of the variable. I want to get the variable out of the exponent. So I'm going to natural log both sides. When I natural log both sides, this is going to become x times natural log of x minus 2 because after I take the natural log, that exponent can plop down in front. Now I'm going to take the derivative of both sides. The derivative of natural log of y is 1 over y, but that's with respect to y, so we're going to call that y prime over y. This is going to equal, and again I have a product rule here, so the derivative of x is 1 times natural log of x minus 2, plus x times the derivative of natural log of x minus 2, which is 1 over x minus 2 times 1, or just 1 over x minus 2. Now I'm going to multiply both sides by y. So y times what was already here, and I'm going to simplify this just a little bit. I'm going to put this x in the numerator here. And then the very last thing I'm going to do is I'm going to replace y with what y was defined to be at the beginning of the problem, which is x minus 2 to the power of x. So I can say y prime equals x minus 2 to the power of x times natural log of x minus 2 plus x over x minus 2. And here we have our answer. Okay, I'm going to encourage you to pause the video and just work through number 5 on your own. Then unpause the video and see how you did. Okay, hopefully you had time to work through this. The very first thing that I'm going to do is take the natural log of both sides. Natural log of y equals sine of x, because the exponent drops down, times natural log of x. Then I'm going to take the derivative of both sides, so y prime over y. The derivative of sine is cosine of x. And the derivative of natural log of x is 1 over x. So that's going to be sine times 1 over x, or sine of x over x. Then I'm going to multiply both sides by y. And then last but not least, what was y? Y was x to the sine of x. So y prime equals x to the sine of x times cosine of x, natural log of x, plus sine of x over x. And that will be our final answer. So if you're feeling confident, go ahead and try number 6 on your own. If not, we're going to walk through it together right now. So just as before, we're going to natural log both sides. Natural log of y equals 3x squared minus 1 natural log of 5. Make sure you put parentheses around that 3x squared minus 1. Now I'm going to take the derivative of both sides, so y prime over y. This is not the product rule. There is only one x, there is only one function, and it's here. If you try and do the product rule, you're still going to get the same answer because at some point you're going to be multiplying something by 0. Natural log of 5 is just some number. So some number times this function here. What's the derivative of this function here? It's 6x. And the natural log of 5 is just going to come along for the ride. So now we need to multiply both sides by y. Y times 6x natural log of 5. And then plug in what we know y is. So y prime equals 5 to the 3x squared minus 1 times 6x natural log of 5. So there are a couple of things that we covered in this section. We talked about how to take the derivative of common logs, log logs, and we did that by first changing them into natural logs and then taking the derivative of that. And then we talked about logarithmic differentiation and how we can bring those exponents down in front by taking the natural log of both sides. So go ahead and write down any questions that you have, and I look forward to supporting you on this. Thanks for listening.